So in the last lecture we saw the example of single degree of freedom system, and I'll show you that how do we analyze it in a control system course, right? Because we are not concerned with the internal dynamics of the system, so that the control strategies that you devise for one system are applicable universally. So I'll depict my plant or the system as a block, right? So this is a block which represents the plant, which, as I have already said, is also called as the system or the process, right? And from the plant or the system, what you get is the variable, right? You get this variable out of the system, and this variable is sensed by the sensor. The sensor which senses the output of the plant. Then there has to be a reference signal. Reference signal. Now, what is a reference signal? For example, in our case, a reference refers to the signal that is required, right? That you want to achieve. For example, in our single degree of freedom system, the reference signal is the equilibrium point. We want the mass to remain at the equilibrium point. So, our reference signal is nothing but 0, right? So, you will compare your sense signal, right? This is the comparison block. This is the comparison. So you compare your sensed signal with your reference signal. Your reference is 0. You want the x position in this particular example to be 0. Okay? If you are trying to control the temperature of a room, and you have set the temperature to be 25 degrees centigrade, and you want to achieve 25 degrees centigrade, so that becomes your reference signal. Right? But for the mass spring system, our reference is the 0, equilibrium point. We want the mass to remain at equilibrium point. We don't want it to vibrate. So when we compare this two, this is the comparison block. Let's say this is plus and this is minus. So what comes out of here is called as the error signal. Right? What comes out of the comparison block is the error signal when you compare the reference and the actual output from the plant. Why is it called the error signal? Because this is the error, right? For example, I want displacement of mass to be 0. Let's say this is my mass. This is the equilibrium point. And at any instant of time, the mass moves down. If it moves down, it comes to, let's say, x1 position. Your sensor senses at x1 position. But you want it to be 0. So error would be minus x1. 0 minus x1 minus x1. Right? So this will be your error signal. This much is the amount of error in the signal. You wanted it to be 0, but it has come down by x1. So this becomes your error signal. Now your controller, the controller block comes here. Pardon me, I think I'll have to drop it because I have less space here. So my system or plant was here. This was the output, and this was the sensed state. So your controller will take in input as the error signal. Controller will take input as the error signal and decide the control action to be taken. So that control action will go into the actuator. Based on the error signal, the controller will decide the control action to be taken. But the control action has to be taken by actuator. So this will give, controller will give command to the actuator, which will apply the final control action on the system. Right? Which will finally apply the control action on the system. Now this is a very generic figure. We have done it only for a single degree of freedom system, right? But I will show you in my next video that this would be applicable to any other system. For example, in my next video, I'll take the example of an air conditioning system which is trying to cool the temperature of a room.